Hi everyone, thank you to be here once again for a brand new video, this time about a small computer. Well, kind of, it's an expansion that you add to the incredible Intellivision video game system to transform your console into a real computer. A real one? Does it really work? We're gonna see that in a minute. Its history, it's a bit complicated, but I'm gonna explain all this in the introduction. In fact, it's made in two pieces. This Intellivision computer adapter that you plug in the console on the side, and then you connect the keyboard to program in BASIC, to play some dedicated video games, and so on. You can also plug on this musical keyboard that I thought I had, but I couldn't find it anymore. We need to buy one to show you how it works. Anyway, let's see first an introduction, a small history of this piece of hardware, and then we will test out this. We'll open the adapter, see what's inside, we'll try to program something, we'll try to play some dedicated games, if there are any, and I'm gonna show you many other surprises, and voila! Well, let's see first a small history about the ECS, the Entertainment Computer System. In 1979, Mattel introduced its video game console, the Intellivision, for intelligent television. It was designed as a true competitor to the Atari VCS, but with better graphics. Right from the start, Mattel envisioned its console as part of a modular system that included, among other things, a real computer, the keyboard component. Equipped with a 6502 microprocessor, 16 kilobytes of RAM, a mechanical keyboard and a built-in multi-track tape recorder, the keyboard component was an ambitious machine but very expensive to produce. In fact, although announced in 1979 alongside the release of the Intellivision console, the computer was never actually released commercially. It was available for only a few months in New Orleans and Seattle in 1981 for $600, with Mattel continually delaying its national release to optimize the system and, more importantly, reduce the exorbitant production costs. But under pressure from the many customers who had purchased an Intellivision because a computer extension was planned, the Federal Trade Commission, FTC, launched an investigation against Mattel for fraud and false advertising. Forced to pay a $10,000 monthly fine until the promised computer was available, Mattel secretly gathered a new research and development team without informing the original team still working on improving the keyboard component to quickly design a new, inexpensive computer. Less expensive to produce, certainly, but it still had to be able to do what was initially advertised for the keyboard component, namely a basic programming language, the ability to save programs to cassette tape, and finally, the option to connect the computer to a printer. And so, at the end of 1982, the Entertainment Computer System, or ECS, was announced. This expansion box plugged into the console cartridge port and transformed the Intellivision into a real computer, and a keyboard synthesizer, and even offered 2 additional joystick ports for playing 4-player games. Okay, the available RAM was only 2 kilobytes instead of the promised 16 kilobytes for the keyboard component. BASIC was very limited, high resolution was not accessible from BASIC, and the cassette interface was reduced to minimum. But at least the ECS was truly commercially available. The release of the ECS in January 1983 meant the death of the keyboard component. A 16K RAM expansion was announced for the coming month, as well as an advanced BASIC, a printer, and of course many games. Unfortunately, major changes at Mattel's direction put an end to the many hardware projects initiated in previous years, including the ECS. The planned expansion were never produced, and ultimately only 6 games were ever released. Well, now that we know a little more about the history of the entertainment computer system, let's take a closer look at it. Okay, let's see first the keyboard itself. It's very light-weighted because there's nearly nothing in it. No electronic, no computer, I mean only the electronic necessary for the keyboard matrix, and the signals are sent to the main component by this cable. There's nothing in front, nothing on this side, no connector on this side, and no connectors whatsoever at the back of this keyboard. It's really a separated keyboard, not the computer itself. Concerning the keys, it's very simple. There is a minimum required, only numbers, some symbols, the alphabet. It's a QWERTY keyboard, although this is the European version. There is an escape key, a control key, CTL, which is not used at all by the BASIC. In the documentation they say, oh yeah, the control key is not used, but it will be used for the extended BASIC that will be released next year, and which was never released, so it's really unused. There are 4 arrow keys with some symbols, 2 shift keys, and the return key is small but labeled in white. It's a calculator type keyboard. Well, it's not a very good one, but enough to test some basic programs. At the end of the cable, which is quite long, this is convenient, there is a double DB9 connector, which is plugged in the main component, which is here. The plug is under this strap. Here, you plug the keyboard here, so you can program something. But let's see the main components. So these double DB9 plugs can be used for the keyboard or for musical keyboard like a piano, and also to connect 2 more controllers like this. These are the controllers for the Intellivision 2, which is here. We will see it maybe in another video. So you can bring 2 more controllers. These connectors are DB9 ones, and you can connect them here and have 2 more controllers to play with. Was it really used in some software? Well, yes and no. There are maybe 1 or 2 games which were released to play with 4 players, like sports game, like the baseball game, I think, was released, and the soccer game, not released at first, but when Mattel did stop everything, the French programmers which were working on the soccer game bought back the game, created a new company called Nice Ideas, which released some games in France later. And some years after, they sold their finished soccer games for the Intellivision to the new owner of the Intellivision. And the game was finally released in 1985 or 6, I think. Well, something I didn't mention is the color of the adapter and the keyboard. The ECS was released in 1983. In 1983, at this time, the Intellivision 2 was released, and so the new design was a creamy white beige color, like the controllers. And the ECS was in fact released in beige color, like the Intellivision 2, but this one was never released in Europe and in France. Well, they choose to recolor the ECS and the keyboard to match with the original Intellivision. This is why in France and in Europe, the entertainment computer system is brown like the original Intellivision. But in the USA, it's white, like the Intellivision 2. So we were looking at the plugs and the connectors. Here is a special knob, very strange, which I think I understood is used to balance the sound between the built-in sound generator here, which is the same as the one found in the Intellivision itself. So the whole system has two sound generators of 3 channels each, I think, I remember. And with this knob, you balance the volume, so both sound generators have equal volume. All right, on the side here is a plug that you insert into the cartridge plug of the console itself, like this. So it's connected to the main component. And on the other side, you have the cartridge slot, which may be used to plug in a cartridge, but in fact must be used to insert a cartridge, otherwise the whole system doesn't work. Yes, you heard right. If you power on everything, it will not work. It needs a cartridge here. Even if you don't use the game, if you only want to program something, you need to plug in a game here. On the back of the ECS is the most interesting part because there are some connectors. Here is the power in, it's 9 volts. Here you have out to tape, in from tape, which is quite clear, and a remote plug. These 3 connectors are used to connect a tape recorder to load or save your programs. And the aux plug for auxiliary is used to connect what? You guess what? Well, a printer. Yes, you heard right. You can connect a printer to this little beast. Well, it's quite disproportionate according to the capabilities of this unit, because you could have omitted to add this, to connect a printer. But what happened is what you heard in the introduction, is as Mattel was very late on the first version of the computer, they were fined every month for not releasing a real working computer as they promised the consumers in 1979 and 80. That is to say, a real computer with which you will be able to program in BASIC, to load and save your programs on tape, and to print something on a printer. This is why, even if the whole computer is very simple, we'll see that in a minute, they had to add these features. Otherwise, they would have continued to pay big fines every month. But what is funny also, they never released a printer for the ECS. And in fact, they made the demonstration with the printer for the Mattel Aquarius, which was another computer they developed with Radofin. Even though the official Intellivision printer was never released, in fact, the Aquarius printer is working fine with the ECS. But not only the printer, also the tape recorder from the Aquarius is also working fine with the ECS. We'll see that later, even though any tape recorder will work fine. Okay, let's open up this and see what's inside. Okay, I have removed the main board from the case so we can see clearly what's happening here. It's interesting because online you don't see very often the main board as clearly as this, and above all what's underneath this card. So I unplugged everything here, and we can see that there is a small Toshiba chip, which is the RAM. It offers 2 kilobytes of RAM. Yes, that's all. We didn't talk about that earlier, but the computer that you will use have only 2 kilobytes of RAM. And when you start to program in BASIC, you only have 1.5 kilobytes, which is slightly better than a ZX81, but not much more. So this is the RAM chipset. This is the General Instrument Sounds chipset AY38917, which is almost the same as in the Intellivision, but slightly different. But it offers the same 3 voices plus a sound channel. And you, as I said earlier, you mix the two sound chips, one here from the ECS and the other from the Intellivision, you mix with this knob so they have the same volume. This chipset not only provides sounds, but also manage the entry connectors used for the controllers or the keyboards. It goes from here to this little board inside the sound chip. Here is the cartridge port, the different connectors that we've seen earlier. And there is a small board on top of everything where you can find the ROM chip containing the BASIC and the microcode so everything works fine. And a small chip on board type chip which is underneath this black glue stuff, so we don't see really what it is called, but it's proprietary. It handles everything. You see all the lines coming to and leaving from it, so the different signals pass through it. And here is a small chip, 20 pins, which should be a UART, which handles the cassette interface and printer communications. And you have a small amplifier here. Well, that's it, not much. No real CPU here, so I guess it's the main Intellivision console which acts as a CPU. 12K ROM, 2K RAM, a sound chip, and that's it. Okay, I'm gonna repack everything and we're gonna switch on the computer and try it, see what it looks like. Okay, the ECS is here. I have to plug it to the main console to use the computer. So the first thing we do is plug it here in the cartridge port of the Intellivision. Then I plugged the keyboard into the ECS via the two DB9 connectors. Okay, I have to power on the adapter, otherwise it doesn't work. The display is on, everything's fine. And the last thing we need is a game, is a cartridge. Because if you don't insert a cartridge into the ECS, like this, it won't work. Yes, it needs the cartridge. I will explain later why. So I chose Auto Racing, and the cartridge you choose is important. You will see that later. It will work with any cartridge, but it has its implications. So let's power on the computer and see what happens. Yeah, Mattel Electronics present ECS, copyright 1982 Mattel. Okay, perfect. So I press one of the keys to start to program something on my wonderful computer, but no, nothing happened. Why? Well, that is strange, but the keyboard is not really activated yet. You have to press enter here on the first controller, and then a menu appears, 1 for basic, 2 for the cartridge, so to play the game, or 3 for music. Well, we want to test the basic first, so you press 1 and then enter. And here I have a flashing prompt, so maybe I am at the right place, maybe I can start to program something, but it's not very user-friendly. I mean, there's no messages, nothing. Well, let's try it. So 1, 0, yeah, it works. I can type CLR for clear, it's like the CLS on normal basics. Return. And see how everything get colored. And if I type 20 PRIN, print, it's for print, because every ECS commands are limited to 4 characters. So sometimes it's strange because the well-known basic commands are restricted to 4 characters, like print, which becomes print. All right. Hello. Holy pigs, return, and see, every instruction gets its own color. That's a way to know that you didn't make any error, any mistake, and that the computer understands everything you typed. If there is something in black, not colored, it's maybe there is a problem because he didn't understand what you typed. Okay, if I type run, it works. Hello, Olympics, okay. List. Okay, I can try a 30, go to 20, run. Yeah, it works. Okay, escape to stop the program. And I can show you menu 0, which is a special instruction. And it will list the commands and functions and instructions available in the computer. So the first menu shows list, well, you know what it is. Cloud is the cassette load. It's to load some programs from the tape. csave, it's to save program on the cassette. Del is to delete some lines, run to run the program, new to clear everything, cvrf it's to check the last program you saved on a tape, menu is this instruction, because I can type also menu 1, for example, and it shows me all the instruction available in BASIC. For, next, rem, data, dim, if, print, which is print, and go to, gsub, which is go sub, clr, which is like clear, should have been a CLS and like all the other basic languages, but no. Input for input, ret for return from a COSUB, call, which is a special instruction which will call more advanced routines that we will see later. Set is to give value to a string variable, put to display this variable, get to get text from the keyboard inside a program, read, which is linked to data, if, well, you know what it is if you know how to program it in BASIC. There's very classic instruction here, nothing quite special. If I type menu 2, and this gives me the variable names reserved for the system. This is quite obscure and not easy to understand, but if you read the instruction, which I did, you understand a bit better, although it's quite complicated for nothing. This type of BASIC on video game systems are mainly intended to play a bit with the sprites, color, movements, like on the Famicom or on the Super Cached Vision, which I made some videos on my French channel if you're interested. And so these variables are used to change the position of the different sprites, color, speed, size, and other variables names like AA, AB, AC. These are the names that you can use if you want to define arrays. You must use one of the three names, nothing else. And it's the same thing for string variables. If you want to use some, you can only use three of them, $, $, $, $. All right, and is there a menu 3? Yes, and these ones are used via the call instruction. You use them by typing call tone, call invent, call noise, and these ones are used to produce some sound, some noise. It's the same for invin. Call dist is used to read the distance between two sprites. This is quite useful and original. Call hush is to cut any noise or sound. Call note is to produce sound, and call show and call grab are a bit special. These are used to show and to grab, to use in your own programs, the sprites which are stored on the cartridge. And this is why there must be a cartridge inside the ECS, because every graphic that you will use, in fact, come from the cartridge itself. And if you type a program on the ECS and you use different cartridge, then your program will show different graphics depending on the cartridge you inserted. Yeah, it's quite special. You can't produce really graphics yourself or sprites or to draw what you want. You must use the ones that are stored in the ROM of the cartridges. A call output P is used to use the printer, we'll see that later. Call link is used to link two sprites together so they move together at the same speed. And call hand for handle, I think, is to read the value of the key pressed on the controllers or on the keyboard. And that's it, because if we type menu 4, we go back to menu 0 that we saw earlier. Okay, one of the first programs you find in the documentation, it's a program that he used to mix and balance the two sound chipsets, the one found in the video game systems and the other one in the ECS. It's quite weird, I know, but it's a good example to show you how the basic works. So if we type v equal 15, this is a variable used to define the volume of the sound into the system. 20p equal 200. This is the frequency of the sound we want to produce. 30c equal 1. This is the number of the channel we want to use. Channel 0, 1, 2 is from the sound chip, which is inside the Intellivision, and channel 3, 4, 5 are the three channels of the sound chip, which is in the ECS. I know. So we choose first one of the channels from the sound chip, which is in the Intellivision. For T, we call a subroutine called hush, which will cut any previous sound or noise. 50 call down. This will produce the sound given the variables we defined at the beginning of the program. This is where it's quite weird with the ECS that you have to call subroutines which will use these variables, but it's not clear if you can also use these variable names in your own programs. I think both, but it's quite a mess. 60 print C or print C, which will print the actual channel, which is 1, so we know on the screen which sound chip is playing. C equal 4. This is to select the other sound chip, that's the channel number 4. 80 call hush to cut any noise. Call tone to produce new sound from the second sound chip. 100 print C, so we can see which channel is playing, and 110 go to 30, which go back at the beginning of the program, so it's a loop, and both sound chip will play together, and we will use this knob to mix so both sound chips are at the same volume. I don't even believe what I'm saying. It's the first time I see that on this kind of systems. It's very strange. So let's run the program and see what happens. See, if I put the knob at the very beginning, one note is very low and the other is normal. And I have to turn the knob to try to mix the two so the two notes are at the same level. It's here, I think. Yeah, it's quite nice. And if I go way up, there is one sound which is very heavy, loud, and the other almost no sound. So we'll turn back the knob. Yeah, this is at the same volume, I think. So you have to do that and close the lid after that. Press ESC. Okay. Oh, there's still the noise, so I call hush to cut any noise. Okay, so now our system is ready because both sound generators are equal. I don't believe what I'm saying. Okay, now we can try something else. Type new to clear the program. I will try to show you how sprites work from the basic. It's quite strange too. First, I can define the number of the object I want to play with. The object is a sprite. I could use from 0 to 7. So there are 8 sprites available. I choose sprite number 1. Okay. With D, I can define its size. Will it be a simple sprite or a sprite made of two graphics? No, I stay with a simple sprite. And with number N, I can choose, and listen carefully, a number between 0 and 127, which is the number of the sprite I want to grab, to pick on the cartridge itself. Yes, you heard right. I can't produce any graphic by my own. I have to take one of the sprites stored in the ROM of the cartridge. And that's why you always need to have a cartridge inserted here if you want to program something, because the graphics will be taken from the cartridge. And I have to specify a number. Well, I don't know which one, 36, for example, and then call the subroutine show, and this will show me the sprite number 36, the tile number 36 stored in the auto racing ROM. Yeah, that's weird. And then you can play with its graphics. If I choose another tile, for example, a 27, and I call show, this will be another graphic. Okay, why not? So you don't know exactly what graphics there in each cartridge. You have to pick randomly one and make a call show to see what there is. But you can do more things with that. You can also change the color. So you type CO for color, the number of your sprite you've chosen. I chose sprite 1. I say equal to 2. And this will turn my sprite in red. Okay. I can also double its size in height and its width. Oh! I can clear the screen, and I clear all my instructions, but not the sprite itself. I can still change the number of the tile, call show. That's a weird one. Change the color to another color. Green on green. No, that's not nice. 6. Yeah, change the color to yellow. You can do many other things like xv1 equal 40, and this will move my sprite at the speed of 40 horizontally. And yv first sprite minus 20, it will also go up and move indefinitely. About the sprites, you can do a lot of things like animations, but it will take more memory. You can, as I said earlier, check the collision, the distance between two sprites. You can link two sprites together also, so they move accordingly. Well, there are a lot of possibilities. Okay, that's enough. Maybe I'm gonna type a longer program that I found on internet, made by someone else, so you can see what kind of possibilities there is with the ECS. So I'm gonna start typing a long program, a long basic program that I found on internet that was made in 1998 in the US for a contest. It's called Homebrew 2, and it's a good example to see what with 2 kilobytes of RAM you can do as a game. Is it playable? Is it fun? We're gonna see that. But the listing is quite long. It will take me quite some time, maybe 2 hours. So first I have to prepare everything. Like I told you, the graphics of the programs are using what's inside the ROM cartridges. And Homebrew 2 use another cartridge, not auto racing, but triple action. Okay, so I take the cartridge of triple action and I insert it in the cartridge slot of the ECS, like this. So now I'm ready to power on the computer because the game will take graphics from the cartridge. There is something else I must prepare right now because it will take some time ready to type the long program on the poor keyboard. I have prepared the Aquarius printer connected to the Intellivision and to the especially the ECS through the auxiliary plug. I can power on the printer itself. It seems to work. I can press paper. Yeah, the paper advances. And indeed, this is the printer that was sold for the Aquarius computer. I will make some videos about the Aquarius later. But today, I wanted to use a printer which is normally compatible with the ECS, to print the listing once I have typed everything. Because if I don't do it now, I don't know what will be the result if I try to plug in the printer once everything is typed in. Well, no, too risky. Okay, so now I'm ready. I can switch on the computer itself and I'm ready to type the program. So I have it listed on my PC screen and I can start to, well, first I need to choose a basic. And then I can start to type. The program itself. Okay, first line is okay. And so on and so on. See you in 1 or 2 hours. All right, I just finished typing the whole program. It was quite long. I spent like more than 1 hour typing with my little fingers on this crappy keyboard, but I managed to do it. What happened is, in fact, the program is made in 2 parts because there's not enough memory. So the first part, the first program I typed in, and it was to grab the graphics from the triple action cartridge and store in the right variables. Then you run the program, so it grabs the graphics, and then you start to type another program on top of the first one that will destroy the first one, but the graphics will be in memory, so it's okay. And I finished to type this long program. I can show you the whole listing. So it's quite long, like 100 lines. I think it fills up the whole memory available. It's quite clever code. I learned a lot looking at it and makes me want to program some games for the ECS, maybe with Retro Programmers United for Obscure Systems, you know, this group I made in France. Well, it's worldwide, but to make new programs for obscure systems, and I think the Intellivision ECS will be a good candidate. Okay, third thing I wanted to do is to print out the result on the Aquarius printer so I can save my program in a way. I could save it on tape too with the tape interface, but first printing it would be nice. So what I have to do is type d equal -1, call output. This will tell the computer that everything that happened now will be on the printer and not on the screen. And I can do list, and then I can press return. Woo! It works! Look at this. The quality is very good. I'm very surprised. This cool little Aquarius printer is still working fine. But today it is connected to the ECS Intellivision. Wow, perfect. Now I can detach the listing. Whoops! Look at this! It's a long program, but the quality, I don't know if you see it, but the quality is very nice. In blue ink. I really like it. Yeah, wonderful. a 2 kilobyte listing here. I will keep it next to me like a souvenir. And now I can put back the output to the screen. Okay, clear. And we can try the game itself. Are you ready to play Bomb Run 2? Bomb Run 2 by Mike Eyes, made in July 1998. Wow, it's more than 27 years ago. Incredible. Press any action button to continue. Okay. It works. Okay, these are the buildings that are made by the program in random heights and colors. Because in BASIC you can use the graphics and the sprites stored in the cartridges. And you can also, if you want, put big colored squares like this. And this game was interesting because it's mixing both possibilities. Wow, that's a plane. And I can press button. It was a top button. And I must, of course, destroy all the buildings so I can land down there. Come on. There's a nice touch with explosions made of multiple sprites. I recognize the plane is a sprite effectively used in triple action. I will crash here now. Yeah. It's very hard, huh? Final level 1 and score 67. Press any action button to continue. Okay, I will concentrate and try to do better this time. But when I typed the program, the height of the building was supposed to be low in the first levels. And I think they're quite high. It's quite difficult. There must be maybe a mistake in the program. And that's better. Okay, ready? I've got to destroy the first one. Come on, no! The buttons are really crap with these controllers. Oh, it's too difficult. I'm dead. 54. Well, but who would have thought that it was possible to make such a game with 1.5 kilobytes and such a crappy basic language? In fact, you can have colorful games with sprites moving smoothly. You can make some noise, print some text. No, I'm really surprised. Really surprised. Okay, another thing I wanted to show you and to test is the 6 voices available with this configuration, because 3 voices are produced by the sound chip of the Intellivision itself, and 3 more channels are produced by the other sound chip that we saw when we opened the ECS. A few programs, games, demos, mainly homebrews, make use of these 6 channels. And one of them is Space Patrol, a Moon Patrol remake, homebrew made in 2007 by Joe Zbysiak, I think. And it's an amazing version of Moon Patrol for the Intellivision. And indeed, it makes use of the 6 channels. I'm gonna show you. Yeah. So this is the famous music of Moon Patrol. You see that there is a whole tune on different voices, but at the same time there is sound for jump, shoot, and for the enemies that are coming. So indeed, that's more than 3 channels. No. Oh, yeah. And even of the noise generators, because there are now 2 noise generators, 2 channels of noise, and you can hear one of them is making the drum, and the other the explosions or the jump. It's an excellent version of Moon Patrol. Only if the Intellivision had better controllers, that would be perfect. And I can, try to mix. This is, for example, one sound chip, and the other one is here. Okay, of course, like many other vintage systems, the Intellivision has many homebrews released every year, and well, I'm not gonna show you all the homebrews in this video, but I will make maybe another video dedicated to these incredible homebrews made for the Intellivision. That's so crazy. Okay, there's something else I wanted to show you, last thing, because I think the video is a bit long. This is a game released for the ECS in 1983. It's called Mr. Basic meets Bits and Bytes. It's a strange name, strange title. So some games were planned for the ECS, of course, but just after the release of the computer, Mattel changed its direction and cancelled many things, including the release of new games for the ECS. So there are not a lot of games software available for it, but Mr. Basic is one of them. And it's a quite special game. You're gonna see it offers 3 different games that you can play with it, of course, with a controller, but also with the keyboard by entering some instruction commands, basic instructions to change how the game behaves. Well, wait a bit, you're gonna see. So first thing, we choose one of the 3 games. For example, Bats. So you can play with the controller. It's a simple game. You are on the roof. You can pick up bombs and throw them on mean bats that try to destroy your roof. I know it's weird. So I'm trying to touch. Oh, I fell in a hole because the bat destroyed a part of the roof. And now there are 2 holes and I must be careful. Yeah, I've got one. Okay. So that's a game. Pretty simple. But if I press clear on the controller, everything stops. And now if I look at the documentation, which is a very large documentation, the largest Intellivision one, 72 pages, yes, of instruction. Well, for this game, they say, okay, you stop. Now you can type on the keyboard and you can, for example, type call run left. This will make your man run left. It will reappear. You can also make him run right if you want. But there also a hole? No. So it's gonna stop at the end of the screen. Like this. Or you can also force the coordinates of the sprite by saying, okay, I want your X coordinates to be 45. So it works. You can make it duck or make it jump. You can choose the size of the jump and the direction of the jump. And make it jump again. But even more impressive, you can make programs, real programs inside the game. It's I know it's crazy. Like if I type 10, call, run, write. All right. 20, call, stop. 30, XP 2 equal 85, which is a coordinate corresponding to the stack of bombs. 40, call, pick up a bomb. 50, call, drop the bomb. And 60, go to 40, so it will do that indefinitely. Okay, I run the game, I mean the program at least. See? It picks up a bomb and throws it all the time, and it does this indefinitely, see? It's incredible, no? And if I press again clear, the game will go on, the bat keeps on moving, and so the game plays itself alone. Yeah, well, I think it's really amazing. It's the first time I see a game like this, that you can stop and program the inside of the game so it reacts automatically, and you can change colors, you can change behaviors as a different objects. It's really clever because it trains you to understand how to type, of course, how the different instructions work in BASIC. It's very, very interesting concept. Let me show you the third game, Mr. Basic, which is quite weird too. So you control a man in a computer room. You know, the big blue thing, it's a huge computer from the 60s, 70s. There is a printer on the left and a lot of artifacts, bits and bytes are floating in the air, coming out from the printer and the computer, and you have to catch them and to throw them back to the terminal, which is the red thing on the left. See, I've just catched one. Now I have to be in front and, whoops, no, I was hit by okay, I have catched another one. Ooh. And with the other button, I must... Yes! I've succeeded, thrown a bit and bytes directly into the terminal, so I got 1 point. Okay, let me pause the game. Of course, if I look at the documentation, I can also program a lot of things, change a lot of things, make the player play it by itself, move the arm automatically, and so on. But there is a small program that I wanted to show you. So we put new, 10 input object, 20 input color, and 30 color of object O. There is an error in documentation. They say CO bracket 0. It's not 0, it's O equal C. And 40, go to 10, so we can change again another object. Okay, run. It's waiting for me to choose an object. The documentation says, for example, that object 6 is the head of the player. And then he waits for a color number. For example, 2, it's red, and I just change the color of the player's head. Funny, he's waiting for another object. For example, 7 is the body of the player. And if I choose color, I don't know, 13, for example, then it changed the whole body in purple. And you can do this with all the 3 games. Change colors of the sprites. So that's it. I wanted to show you this game because I think it's very clever, very original, and very interesting. Okay, I think the video is already quite long, so we're gonna conclude. Oof, we finally reached the end of this video. I know it was epic, we tested a lot of things, but I wanted to make a video dedicated to the Intellivision ECS for a long time, so I'm very happy to have made this video. I hope you liked it. We tested a lot of things. We tested the keyboard and programming something, and we even typed a longer program, Bomb Run 2, made in 1998. We tested one of the few games programmed specially for the ECS, and we even tried a Homebrew, a clone of Moon Patrol, which was making use of the 6 sound channels available with the ECS. That was excellent. Oh, and we even tested the Aquarius printer, which is finally compatible with the ECS. That was funny too. I hope it was not too long and interesting for you. Of course, don't forget to like this video, to subscribe to the channel if you want to see the next videos about obscure systems. If you really liked this video, you can also make special thanks, micro donations with a little heart and $1 under this video. Don't forget also to look at my French channel for more retro computing and retro gaming content. Hope to see you soon, and as we say in French, portez-vous bien et à bientôt. Ciao.